Hello, FIA aficionados. The purpose of this video is to show you how the data that are in the plot, cond, and tree tables can get visualized by drawing them manually on a plot. I just want to start out by saying that I've very grossly simplified what actually happens in terms of how this mapping, this condition mapping works. The distance and azimuth data aren't necessarily available to you, so for our purposes I created artificial data for the distance and azimuth which resemble the true distance and azimuth. So let's start out by looking at the FIA plot. Again, this is a review. The FIA is a cluster plot, a nested cluster plot, in which trees, in other words, trees greater than or equal to 5 inches in diameter at breast height, are measured on the tree plot, which is a 24-foot radius subplot. Saplings, or trees that are between 1 and 5 inches, are measured on the sapling plots, which are offset and nested within the larger subplots. Each of these sapling plots is 6.8-foot radius, so it's not exactly drawn to scale here. We have these 4 subplots. You can see that it's subplot 1, 2, 3, and 4 in this configuration. So what the field crew does is they'll show up at the plot center. Then if they've already identified the locations of the different conditions, and we'll talk about that in a moment, they will look to see if there are trees that they need to measure. So for example, there might be a tree located, let's see here, and we'll just color it in green so that it's obvious. They'll stand at the plot center, indicated here as the center subplot, and they will measure the distance to it using a tape measure. So if this whole thing is 24 feet, I'd say this tree might be at 12 feet. And again, I'm just eyeballing this. So the distance of this associated with this tree would be 12. The azimuth, think of it like a clock or like a compass, where 0 and 360 are north. You know, at 90 degrees, it would be due east. 180 degrees would be south, 270, etc., and all the values in between, like going around a compass face. So for example, here the distance would be 12 meters. The azimuth would be either 0 or 360. I'm not exactly sure how they do that, and we can, the details of that aren't so super important at this point. So let's move the tree a little bit. Let's say it was over here. So here it might be at 22 meters is the distance, and the azimuth looks to be about halfway between 0 and 90. So we'll say the azimuth would be 45, and that's what the field crew would record. This is if it's a tree, a tree greater than 5 inches. So if we have trees that are smaller than 5 inches, between 1 and 5 inches, we have a sapling plot. So from the center of the sapling plot, it's the same kind of thing, except the maximum distance would be 6.8 feet, and the azimuth would be as described before. Okay, so let's get started and look at some real data. Well, first we'll start out with the data set we were looking at before, and these are plots and trees in Delaware. Now, as a review, as you remember, the first plot here, and again, the plot CNs are the identifiers. I'm just going to talk about them in terms of the plot ID. So we remember that plot 304 appears to only have one condition, because there's only a cond ID of 1. That condition status code is 2, meaning it's a non-forest condition. If you remember, we don't measure trees on non-forest conditions, so you won't be finding a plot 304 in the tree file. There just aren't any records because there's no trees measured. So if we look at plot 498, we can go to the condition table and we say, aha, there are 2 conditions on that plot. Cond ID 1, which is the first condition they encounter. In other words, the condition they encounter at the plot center, and cond ID 2. Cond ID 1 is a condition status code 2, meaning it's non-forest. Condid 2, which is the second condition encountered on the plot, is a con status code 1, meaning it is forest. So, okay, we have a forest condition on the plot. All right, here we are associated with the records associated with plot 498. Here we see that on condid 2, in other words, the forested condition, we have 11 trees. And we have the distances and azimuths of each of these trees from their respective subplot center. So normally in FIA, we actually have other data that you don't have available to you, and that is information about how we could actually map the subplot. So what the field crew really does is they go to the subplot center and they map the distance and azimuth to the point that a condition boundary crosses a subplot. So if they're on this subplot, they might see that this line goes through the subplot. And let's say over here it's a certain one forest type and over here it's another. There'd be two conditions on this plot. They'd measure the distance and azimuth from the center to this point and the center to this point, and then they can calculate using just geometry the proportion of the plot which is in this condition, condition ID 1. This would be condition ID 2 because it's the second condition that they would encounter. If this condition is also over here, you've got condition ID 2 over on subplot 2 as well. So you could think of like this piece being a slightly different color and this piece being the other color. We can also see that over here, this might or might not be the same condition. So in our case, let's study this a little bit and think about it. So we see that we've got two conditions on the plot. The first one, as I said, is non-forest. The second condition is a forested condition. We know it's a forested condition because the condition status code is 1 associated with condid 2. We see that all the trees are on condid 2 as expected. And we have this other field called subplot. So we say, aha, all of those trees are on subplot 3. Okay, so that's helpful. What else do we know? Well, if we scroll over to the right, we'll see that there is a condition, in the cond table, there is a condition proportion, cond prop unadjusted. So we see that it is 0.75 and 0.25. Well, what does that mean? Well, it's a little hard to see, and you can actually move the column over if you wanted to, just to understand it better. We have cond status code 1. So we know that cond status code 2, or condid 1, is 75% of the plot, and condid 2 is 25% of the plot, because I looked at that cond prop unadjusted. So what does that mean? We don't really know. Given the data that you're working with, you can't be sure. But what we do know, and again, this requires some common sense to try to think this out, is to say, okay, condid 1 is 75% of the plot, condid 2 is 25% of the plot. We know that condid 2 is a condition class status 1, so it's a forested plot, and all the trees that are measured on forest occur on subplot 3. So I'm going to infer something. I'm going to infer that the boundary goes between subplots here, that subplots 1, 2, and 4 are non-forest. Subplot 3 is the one that's the forested one, and it has its 11 trees. Now you might have to replay that to understand, but basically I saw in the condition table that there are two conditions on this plot. Condid 1, which is the one that's encountered first, is non-forest. Condid 2, which is the one that's encountered second, which is this condition, whatever's over here, is 25% of the plot. So that's very convenient because there's 4 subplots. So I'm inferring that there's a whole one subplot. That's all the forest condition. And I see that there are 11 trees on condid-2, all of them on subplot 3. So hence I've guessed that, for instance, on the landscape, all this might be in a farm field, and this might be in a forest patch. So let's try to plot those trees. So what I can do is say, all right, let's look at the distances and azimuths. In fact, what I'm going to do is I'm going to take these, since I know that they're all on a single subplot. This makes it a little bit easier. I'm just going to paste these guys over here. Okay, so we're going to put all of our trees on subplot 3. And again, I already saw that that's in the con table. So we're just going to start drawing them. And what's the easiest way to do this? Well, I'm going to do this. Control-C, Control-V. I'm going to turn this guy green. And I'm going to say Control-C, Control-V, V, 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 which is around 11 trees. And I'm just going to take these one by one. And I'm going to say, okay, tree number 1. It's 11 meters, or 11 feet at 90 degrees. We're going to put that right around here. The next one is 19 feet at 10 degrees. So this is 0 degrees. This is 45. So 10 would be about over here, and it would be about here. The third tree is 6 feet at 311 degrees. And again, this is 360, so we'll just put it over here, and we know it's right near there. See what we're doing? 9 feet at 237 degrees. So we know that this is 180, this is 270. Let's just go down here. How many feet did I say? 9 feet, etc. And I will go constructing using this sort of quick and dirty way to make a map of the plot. And I'm not going to do it. I'm just going to drop these in here like this until I've sort of located all my trees. And what we're going to see is that we have built the plot. And again, I didn't count these out, but you get the idea. Your finished product will look something like this. And this I know is strange. And you're going to be like, what is going on? What you really have to do is just dig into the data. I've tried to set it up so that, you can randomly choose a plot. And what I would do is I would just sort of scroll down in the tree file, right? I'd look for a certain plot ID. Let's say this plot, 405. I literally just did this randomly. And I'm going to color code these guys so I can look at them nicely. Ugh, I don't like yellow. Turn it green, maybe. We're going to look for plot number 405. And here's a little trick for you. If you position the cursor right here in cell A2, and then you do View, Freeze Panes, it keeps all those, the headers where you want. So we're going to scroll down, and I think I did plot number 405, was it? Is that what I did? Let's see here. I've lost it now. Isn't that funny? It's in here somewhere. What I did is a filter, so I'm just showing plot 405. That makes it even easier to keep track of here. So you do data, filter, and then I can choose plot 405 out of the list to subset the data set. And now I've got a bunch of trees. So let's go over to the con table. Let's figure out what's going on with plot number 405. So we'll do the same thing, data. Let's see here, filter, plot number 405. And we see we've got 2 conditions again. All right, let's talk about this plot. We see that the status codes are 1 and 2. Okay, and that's conveniently condid 1 and 2. So condid 1 is a forested condition. Condid 2 is a non-forest condition. Okay. What else do we know? We know that the condition proportions are, again, how convenient, 75% and 25%. Okay. So in this case, condid 1, the forested condition, is 3/4 of the plot, and the non-forest is 1/4. So let's go over to the tree, and we'll see what subplots those trees are on. And we're going to try to infer, using this information, how the plots are divided. I see that these trees are located on a mixture of subplots, 1, 3, and 4. What that means to me is that subplot 2 is the non-forest condition. Okay, so I'm going to take this, and I'm going to copy this, and I'm going to go back to my plot drawing, just here, get rid of this. I'm going to paste it in there. And I believe I have all the information I need right here. Now this is a lot of trees. I actually, you know, one of the things we haven't, I should have done here, sorry, is to look at this, and we have to understand the diameters as well, so that we know if we need to put it on a macro plot or a big plot or a small plot. So we have these diameters, and we'll see that, there are a couple of saplings because they're less than 5. So let's capture all of this information. Let's just see if this works. Control C, and let's go back to our plot here, get rid of this. And we will do this, and I will shrink this down so I can look at it, and I will move this over here because I just need to refer to it. So let's just start out doing this. So let's look at subplot 1, which is this one. I see that there is a tree that is 14 feet at 360 degrees, and it's a 10-inch tree. So I'm thus going to put it on the tree plot. So here I'll just take one of these over here, which I'm holding in reserve, and I'm going to put it over here. It's at 14 feet, 360 degrees. So let's say about right there. In fact, I was going to say that, remember how I said the subplots are their own condition? In this example, I'm inferring that. We have subplot 2 is the non-forest condition. So what I'm going to do is I'm just going to take my condition dividing line and go like this. So this is all non-forest, we know, because condid 2 is a condition status code 2, as we saw in the con table. So we're only going to be operating on subplots 1, 3, and 4. See, subplot 1, 3, and 4. And now we're going to put our trees. So as I showed you a moment ago, we'd keep doing that. Let's do this, though. You see, we have a diameter of 2.3 inches. Well, we know because it's 2.3 inches, it's only measured on the little baby plot. So, I'm not going to put the other trees, but let's only put the sapling in there. So let's scroll over here. It's on subplot 3. It's at a distance of 0, an azimuth of 183. Subplot 3, let's get rid of all these trees because we don't want them anymore. I've deleted those. And we said subplot 3, it is at 0 distance, which is fine, 183 degrees. Well, we know that this is 180, this is 180, and a little bit beyond that. So we'll just put it right here. And it's actually at 0 distance. So we know that it's slightly, it's not exactly 0 at the plot center, so we're just going to bump it over a little tiny bit to the right. If it had been like 6 feet, we would have we would have put it down here if that was the distance. But instead it's 0, and it doesn't quite make sense. So let's just say, well, we're going to bump it a little bit to the southwest of 0. Anyway, I know that's a lot, and I think that the best thing to do is for you to experiment and try to duplicate this. Best of luck, and if you have any questions, please reach out.